Hello student, today we are learning the moment of inertia. What is mean by the moment of inertia? Moment of inertia is analogous to the mass in translational motion, and it is defined as the moment of inertia of a rigid body about an axis of rotation is defined as the sum of product of the mass of each particle and the square of perpendicular distance from the axis of rotation. Now see the diagram. In diagram, rigid object is considered. This rigid object rotating about an axis with a constant angular speed omega. This axis is perpendicular to the plane of paper. Let us consider object consists of n number of the particle, and the particle is having the masses is m1, m2, m3, mn, and this particle is situated at a distance r1, r2, rn from the axis of rotation. The moment of inertia mathematical formula is given by I is equal to summation of mi ri square, and for continuous mass distribution moment of inertia I is equal to integration of r square into dm. The next term also involved in a moment of inertia, that is radius of gyration. Radius of gyration is notation is capital K, and it measures the distribution of mass about the axis of rotation. And that's why if we substitute the instead of the r k value, then formula becomes I is equal to mass into square of distance from the axis of rotation. I is equal to mk square. Therefore, k is equal to under root of I upon k, and the unit of radius of gyration is in SI system meter. Hello student, now we are learning the next derivation of to find the moment of inertia of circular disc about an axis passing through the center of mass and perpendicular to its plane. Let us consider the uniform circular disc of mass m and radius is capital R. This circular disc is rotating about its own axis, which is perpendicular to its plane and passing through the center of mass. Now let us find the surface density. Surface density sigma is equal to mass upon area. Therefore, mass of the circular disc is equal to the pi r square, and that's why surface density sigma is equal to capital M upon pi r square. Now let us consider as this circular disc consists of the number of concentric ring of different radius increasing from 0 to r. Now let us consider one such ring of mass dm, and the thickness of this ring is dr. Therefore, area of this ring is given by 2 pi r into dr, that is circumference into the thickness, and the circumference of this small ring is 2 pi r and the thickness is dr. Therefore, area of this ring having the radius is small r is given by 2 pi r into dr, and therefore surface density sigma is equal to dm upon the area of ring. Surface density of a ring sigma is equal to dm upon 2 pi r into dr. What is the value of the dm? dm is equal to 2 pi r into sigma into dr. as it's a ring and this entire mass is at a distance r from the axis of rotation. Therefore, the moment of inertia of this ring IR is equal to dm into r square, that is mass into distance square. IR is equal to dm into r square. The moment of inertia of a disc can be given by the integration. I is equal to integrating all this in moment of inertia of a ring from 0 to r. Substitute the IR value, the integration of r square into dm integrating from 0 to r. Now substitute the dm value 2 pi r into sigma into dr into r square 0 to r, which is equal to 2 pi sigma outside of integration and integrating only r cube into dr 0 to r value. Moment of inertia I is equal to 2 pi sigma into integration of r cube, get adds here r4 upon 4. Now substitute the sigma value, that is capital M upon pi r square, and then formula equation becomes here 2 pi into M upon pi r square into r4 upon 4. R square get cancel, pi gets cancel, 2 get cancel, remains only half m r square. Hello student, today we are learning the kinetic energy in rotational body. It carries the 2 marks. Let us consider the rigid body. Rigid body is rotating with the angular velocity omega about an axis perpendicular to the plane of paper. This rigid body consists of n number of the particle, and each particle is having the masses is m1, m2, mn, and it is situated at a perpendicular distance r1, r2, rn from the axis of rotation. When the rigid body is revolving, each particle is performing the circular motion with a different radius r1, r2, r3, rn, but they are revolving with a constant angular velocity omega. Each particle is having the different linear velocity v1, v2, vn. This linear velocity of a first particle is given by v1 is equal to r1 omega. For second particle, v2 is equal to r2 omega. And for the nth particle, linear velocity of a nth particle is given by vn is equal to rn into omega. According to the basic definition of the translational kinetic energy of a first particle is given by kinetic energy 1 is equal to half m1 v1 square. Now substitute the value of the v1, that is r1 omega. After substituting this value, we get here half m1 r1 square into omega square. Similarly, for second particle, kinetic energy 2 is equal to half m2 v2 square, which is equal to, after substituting the value of the v2, we get here half m2 r2 square omega square. For nth particle, kinetic energy n is equal to half mn vn square. Substitute the vn value in this formula, we get here half mn rn square omega square. The rotational kinetic energy of the object is the sum of individual translation kinetic energy. Therefore, kinetic energy, rotational kinetic energy is equal to the kinetic energy of a first particle plus kinetic energy of a second particle plus kinetic energy of a third particle plus kinetic energy of the nth particle. Substitute the formula for it. It will give us as half m1 r1 square omega square plus half m2 r2 square omega square plus half mn rn square omega square. Rotational kinetic energy is equal to, taken as a half common from one side and another bracket side we taken as a common omega square, and we get here half inside the bracket m1 r1 square plus m2 r2 square plus mn rn square into omega square. We know the basic formula for the moment of inertia. Now, moment of inertia, according to the definition, it is a sum of product of mass and the distance square. Therefore, I is equal to m1 r1 square plus m2 r2 square plus mn rn square, which is equal to summation of mi ri square. I is equal to 1 to n. Substitute this value in bracket. We get here half into summation of mi ri square, and summation of mi ri square gives us the moment of inertia. That's why formula becomes here half I omega square, and this is the formula for the kinetic energy in rotational motion is equal to half I omega square. Now, if you compare this formula with the translational kinetic energy formula, that is in translation kinetic energy formula, kinetic energy is equal to half mv square, and in rotational motion kinetic energy is equal to half I omega square. That's why if omega is analogous to the v, then we can say that the moment of inertia is analogous to the mass in a translation motion.